Hello everyone, my name is Sandeep. Let's solve Leetcode question 515. Find the largest value in each tree row. So the question here is to find the largest value in each row of a binary tree. So this is not a binary search tree, this is a binary tree. So what it means here is, so every row will have a number of elements. On the row number one, there'll be one element. We have to find the largest of all the elements in that particular row. So here, row number one is the largest. Row number two, 3 is the largest. Row number 3, 9 is the largest. Okay, let's take one more example. So here in the first row, 10 is largest. Second row, 25 is the largest. Third row, 72 is the largest. So to solve this problem, so it's basically to find the largest number in a given array. So you can break down this problem to that problem basically. Find the largest number in a given array or a given list or a given queue. So to get that data structure, we have to break down this tree. For example, if we have to find the largest in row number 2, that has two values, 25 and 15. So it will be very easy to find the largest if we have 25 and 15, just 25 and 15 in one particular data structure. For example, an array or a queue, we can iterate through that data structure and find the largest number. Same with row number 3, we can check if 50 is greater than 8 or 8 is greater than 72, and that way we can keep track of the largest number. So to achieve that, we will use breadth first search. What breadth first search will do is it will insert elements in the queue row by row. So basically it will insert the root node and then its children, and the same thing continues, like the children will be polled and those children of their children will be inserted. So let's have our setup ready. We have a queue and we have one temporary variable and queue size, and this is our input tree. We have to return back an array list. So here basically the size and all doesn't matter. Here we are taking array list, and queue is also dynamic, so we haven't assigned any particular size to the queue. So what happens in breadth first search? So first root will be inserted in the queue. So we have root inserted in the queue, and queue size will be 1, and we also have a temporary variable where we assign the value of that node. So value of the first entry in the queue, that is 10. And now what we do is we traverse the queue till we reach the size, queue size, and see if there is any element greater than the temporary variable. In this case, the queue size is 1 and temporary variable is 10. So 10 is equal to 10, so we don't have to change anything here, and so we can update our result array with 10. In the second iteration, what happens is the child of left and right child of 10, that is 25 and 15, will be inserted. So you can see here 25 and 15 are inserted. Queue size is 2 now, and we have also assigned the temporary variable with the first element in the queue, is 25. So here we do the iteration twice. So iteration till we reach the queue size 2. So first it's 25, so 25 equals 25, nothing can be changed. And next, so every time we iterate, we poll from the queue, so 25 will be removed, and next we come to 15. So 15 is smaller than 25, so we cannot update temporary now, temporary variable. So we append this temporary variable to the result array 25. So next comes the last row. So 58, 72 and 20 are inserted in the queue, and temporary variable is assigned with 50. And now we have queue size as 4. So first time we come and check 50 with 50, both are same, we should not change temporary variable. Next, the value is 8. 8 is smaller than 50, so we don't change 50 temporary variable again. And next here 72, so 72 is greater than temp, so we change the temporary variable to 72. And next is 20. 20 is smaller than 72, so temporary variable is not changed. And we reach the end of the queue, and all the elements are polled, and the result will be updated with 72. So now we don't have any more elements in the queue, so we return back the result array. So this is the explanation. Let's go to the code now. So here's the method signature. We have to return back the list, and we are given with the tree node. We'll follow the same approach that I have explained here in the code. So first I check if the root is null, then I return an empty array list because it expects a list. If the root is not empty, then I start my breadth first search approach. So what do we need for breadth first search? First we need the result array, which is of the type integer. And as I told you, we also need queue. Queue will basically contain nodes, because we have to insert the child elements. We cannot just insert the value. It will be easy if we insert the node directly. So we'll use the linked list implementation of the queue. And as I told you, we will insert the root element to the queue directly. Okay, so we traverse till the queue is empty. And here I create a temporary variable. So I can create the temporary variable here itself. No, it's better here. So before that I have to check the queue size, and I create the temporary variable and assign it with the first element in the queue value. So now I traverse the queue from 0 till the size, and I poll from the queue one by one. So when I poll, I get back the tree node. I save it in a variable called node. Okay, so what do we do now? So once we have the node, we just have to compare it with the temporary field. So we basically have to check, we basically have to update the temporary field with the largest number. So if temp is largest, assign don't update it, else update it with the node's value. So once that is done, we have to push the remaining elements in the queue. Remaining elements in the sense the children of the queue, children of the node. And I have to do the same with the right child as well. So every time I have to update my result array with this temporary field. And I just have to return my result. So let's see if this works. Yes, this works. So this code is basically same thing that I've explained here. I just add everything to the queue and I poll it and keep track of the largest value, and I return that array list. So if you found this video useful, please like and share it. Thank you.